Today we are going to work on solving inequalities. If you remember, inequality means not equal, and when it's not equal, instead of using an equal sign, we use either a less than or a greater than. In this case, in example number 1, it is a less than or equal to. It has a line under it, meaning whatever this is can either be less than negative 95 or it can actually be equal to it. So when we solve these, we solve them exactly like we do if it was an equal sign. We just pretend it's an equal sign and let's solve it exactly the same. So the first thing we do to get x by itself is to add 5 to get rid of that negative 5. This minus is attached to what's after it. It has nothing to do with what's before it. It's attached to what's after it. Minus, the opposite is plus. What we do to one side of the equal sign, we must do to the other. This is not an equal, it's an inequality, but we still do the same rules, the same steps to isolate x. So now our next move would be to divide, because there's an imaginary multiply. The opposite of multiply is divide. So now we have x is less than or equal to negative 6. Now I did not flip this symbol. There was no reason to, because as we learned on yesterday's video, we only flip the symbol, in the order only switches when we multiply or divide by negative. Here, we divide it by positive. It doesn't matter what this is or this is. It matters what we divide by. We divided by a positive. So we're going to look at example 2, which is negative 12x plus 5 is less than 101. So this one doesn't have less than or equal to, it's just less than. We start by getting rid of the 5. What we do to one side, we must do to the other. We bring down our negative 12x, and it's less than 96. So now we divide by the negative 12. We get negative 8. Now, this time the symbol flips. It flips to a greater than because we divided by a negative. This means that any value of x that is greater than negative 8 will make this true. So let's try 0 because the math is easier. 0 is greater than any negative number. 0 is greater than negative 8. If you plug this in and this was 0, you would get 5 is less than 101. That is a true statement, so that works. For the third example, we have that negative 21x minus 15 is greater than negative 120. We need to isolate x. We always divide last, so let's get rid of the minus 15 by plussing 15, adding it. We bring down the negative 21x. We bring down the greater than. We add, and we get negative 105. Because this is multiplied, to get rid of it, we divide. We divide by exactly what's there, so we can end up with 1x, which is our goal, is to isolate x. When we divide this, we get 5, and because we divided by a negative, we flip the symbol. So any value of x less than 5 would make this a true statement.